Hello everybody, it's been a while. The last time I made anything, it was about a year and a half ago. That was like June of 2016. It's now October of 2017. So it's been a little bit. Yeah, that's how math works. It's been 1 year, 4 months. Anyways, today I'm going to be showing you how to make some Damascus steel out of these saw blades. I got these for free. They're just going to be thrown away. So there's a few different ways that we can approach this. Okay, so these saw blades, they're all the same brand. They claim to be S100 steel. And a quick Google search shows that there's not any information on S100 steel out there. So I'm thinking that these are either, well, the teeth have to be carbon steel, or, well, we know that they aren't carbide. They could be case hardened, and all of this could just be mild steel. And if we look, we could see that these are rusted slightly more than the rest of the blade, and they look like they've been heated, like they were tacked, probably laser welded if I had to take a guess, or they could be case hardened, or this is the part of the saw that gets the most use, thus it gets scuffed and is more porous to moisture. Any of these things could be the case. I'm going to assume that this is mild steel, and so it'll be unusable for the knife edge. So what we could do is we can alternate it. This is a bar of wrought iron. Take it in the light over here. We could alternate it. We could forge this wrought iron down into a flat bar, and then stack it with the saw blades cut up, and then we could get something that looks similar to this. Very pretty. The wrought iron would add a lot of weird volatility to the pattern. But it would be unusable as the knife cutting edge, because the cutting edge has to be hardenable. We could do like sandwich construction, where we would have a layer of Damascus on each side, and then a carbon bar, a layer of carbon steel in the middle, and that's what would be the edge. But I don't know, I'm going to spark test this and we'll see. Okay, so here I have my piece of steel that I cut off of the blade. You can see the teeth there. I still suspect the teeth are case hardened. So the case hardening would only penetrate to about that line. So we're gonna sample that part of it. Probably bite in there on the old 2x72 belt grinder. Okay, so those sparks do look like there's some carbon in there. Let's try the teeth now. They look the same, so this is hardenable steel. Alright, so I've done some thinking, and I think I figured out how I'm going to maximize the amount of steel that we get out of each of these blades. So this is really sloppy, but each of these these are definitely squares. Each of these rectangles are 1 inch by 4 inches, and if using this pattern, I'm going to be able to get 12 of these rectangles out of each blade. So each billet then, doing some very complicated math, is going to be 1.5 inches thick by 4 inches by 1 inch, and it should be 12 layers. I'm just going to be doing this steel because it's carbon steel, and really I just want to see if I can make a usable knife out of one of these. I know I've seen a lot of people make knives where they just cut them out of saw blades And I mean, that would work if it's a carbon steel saw blade, except that these things are only 1/8 of an inch thick. If you do anything like that, other than like a carving knife or a scalpel, it's just like. In order for you to have a successful forge weld with these, all of them have to be perfectly clean on the surfaces where they're butted up together, or else the steel won't be able to weld together. So that's going to mean taking off any sort of paint and any sort of oil or dirt or anything that's on these. So that'll just, this will take care of it real easy. Alright, so now I have the freshly ground pieces of flat bar ready to be tack welded along the sides. The reason why you do that is so they stay together in the fire before you actually deliver the hammer blows to set them together. We're actually just going to do that with an arc welder. Well, we're going to forge weld with a hammer, but tack weld the sides and probably weld a handle onto it too, so we can hold it. We're going to do that just with a DC arc welder. So now I have this really nicely welded up just stack of saw blade parts, strips. So now what we're going to do is we're going to put it into the forge, heat it up to about 1800 degrees, sprinkle some borax flux on it. That'll help get in between the layers and purge it of oxygen and any sort of oxides that form on the steel as it's heating up from the forge and from welding. And then we're going to heat it up to around 24 to 2600 degrees Fahrenheit. Talking about Fahrenheit, we're in America. Degrees freedom. And then once we're up to temperature, we're going to take it out, hit it with a 2-pound hammer, and set the welds. Once the welds are solid, we're going to switch to a 6-pound hammer and go to town on it. First, what we're going to do is we're going to put flux onto the heated billet. We're only going to take it to about a mild red, just so the flux will stick and get And then back into the fire. You can get a little more aggressive now that the welds have started to set. You don't want to do too much though, because you risk setting the weld and then breaking the weld. So just do a little bit at a time for the first few heats. Once it back up. Then we're going to take it up to one more welding heat. Fire. Billet at this point feels very solid, so we can start working it down. Scrub it off. We shouldn't need any more flux. Everything looks very good. Alright, back into the fire, and we'll take it. I'll probably do one more welding heat since I don't know what kind of steel this is. Take it back into the fire and start drawing it out. It's completely welded, and I've drawn it out a little bit. What I'm going to do is I'm just going to let it cool, and then I'm going to grind off the sides so we can start hammering on the sides and the ends, and we'll cut the handle off so we can use it with tongs.